So I'm going to make a quick video, just an example problem, and show you a different situation for finding the concavity of a function. I've already made a video explaining how this works, so it's going to be pretty quick, and if you don't know how to do this, watch the previous video. It should be helpful. Okay, so let's get into this. So the first thing you have to do when determining your concavity on an interval is find your first and second derivative, and find your critical points from your first derivative. Okay, so f prime of x is going to be 3x squared minus 6x. And our critical points from this, we're going to set this equal to 0. So 3x squared minus 6x equals 0. Factor out 3x. So then we have x minus 2. And then when we set 3x equal to 0, x is going to be 0. And when we set x minus 2 equal to 0, x will have to be equal to 2. And these are our critical values. Okay, next we have to find our second derivative. Okay, so f double prime of x, that's going to be the derivative of this, so that's going to be 6x minus 6. Okay, that was pretty simple and straightforward, right? So next we are going to use the chart we've used in the previous videos, kind of the same as the first derivative test and exactly the same as the previous video I showed about finding concavity. Okay, so here's our chart. We have our interval going from -0 to our critical value of negative infinity. There's no -0. So from negative infinity being less than x, which is less than 0, and 0 less than x, to less than 2, then 2 is less than x, which is less than infinity. And I know that infinity is a little wonky, but bear with it. Next we have to find our test values, right? What we're going to use in this chart. So I'm going to use x equal to -1 because that's going into negative infinity and it's less than 0. Bigger than 0 and less than 2. Well, we can use 1. And then bigger than 2 but less than infinity, which is any number above 2. I'm just going to use 3. Okay, and then we have to find the sign. So for most of these you really don't have to do work, but I'll just show you a little bit. So plugging this number in, we're going to plug it into our second derivative equation, our test value. So f -1, which is going to be 6 times -1 minus 6. So this is going to be equal to -6 minus 6. We know that's going to be negative, because a negative minus negative is a negative, and that's actually going to be -12. And then let's look at this one over here, our interval from 2 to infinity. Let's see here. So f double prime 3 is equal to 6 times 3 minus 6. We know this is going to be a positive. It's a 6 times 3 is 18 minus 6. So we just know that's going to be a positive right now. So like I said, you don't even have to know what this number is. And then for here, and that's helpful once you get larger numbers and you don't want to worry about it as much. So I'm just showing you that for right now. For this one, okay, so f double prime of 1. I don't know if any of you see the issue that's going to come up here, but 6 times 1 is 6 minus 6. This is 0. Okay, So that's going to be an issue. That seems like it might be an issue. Okay, but let's go through this. Right here this is a negative from negative infinity to 0, so we know this is going to be concave down. This is a positive, so it's going to be concave up. And then this 0. This is going to be what we call concave 0 or concave flat. Let me show you what this is. Okay, let me flip this board over. This is a really poorly drawn graph, but what we have here is kind of roughly what this function looks like. Let me fix this a little bit. But the idea here is that that didn't help a whole lot. I'm going to try post a video of my phone screen on Desmos showing you this. I'll try to get to that if I have time. But what we have here, so from this green line to over here, all this is all concave down, right? Facing down. And over here is our 0, our infinity, negative infinity, which is less than x, less than 0. That's this right here. And all this is concave down. And then over here, this is our other critical value, so this is going to be from 2 to x to infinity. And this is all concave up. So then you have this line right here. And this line is kind of split. You got half of it in, if you want to think of these like parabolas right here, right? This looks like a parabola. Half of it, it's in this parabola, but it's also split between this concave up parabola. So this line right here is a little bit confused. So it's it's concave down to this part, and it's concave up to this part. So that's concave flat, or no concave, whatever you want to call it. It's just, it got kind of confused. It was torn between either side, and it was like, you know what? I'm going to be neutral in this. I'm not here. Neither concave down nor concave up, just concave 0. So that's what that means. Sorry for this poor graph, for this poorly drawn graph. But I hope this was a helpful example. Thank you for watching, and have a good rest of your day. Bye.